Eighth grade, welcome back to week 13. We're talking about wave properties, and this will be our last property that we're going to be talking about this week. So we were going to be talking about interference, wave interference. By the end of this, you should be able to explain to me what wave interference means and how it affects waves. So when raindrops fall into still water, they create tiny waves that spread out in all directions from the drops. What happens when waves from two different raindrops meet? Well, they interfere with each other. When two or more waves meet, they interact with each other. The interaction of waves with other waves is called wave interference. Wave interference may occur when two waves that are traveling in opposite directions meet. The two waves pass through each other, and this affects their amplitude. Amplitude is the maximum distance from the particles of the medium from how they move from their resting positions when the wave passes through. How amplitude is affected by wave interference depends on the type of interference. Interference can be constructive or destructive. In constructive interference, we find this occurring when the crests or highest points of one wave overlaps the crests of the other. You can see here that as waves pass through each other, the crests combine to produce a wave with greater amplitude. So in the first part of the picture, we have A and B waves approaching each other. In the middle, we have both A and B combined. A plus B forms that wave, and then they separate and continue in this original directions they were traveling. In destructive interference occurs when the crests of one wave overlaps the troughs or lowest point of another wave. Here we see, as waves pass through each other, the crests and troughs cancel each other out to produce a wave with zero amplitude. In shallow ponds, the depth of the water influences the wave speed. We're going to skip on to standing waves. This is an example of a standing wave. Waves may reflect off of an obstacle that they are unable to pass through. When waves are reflected straight back from an obstacle, the reflected waves interfere with the original waves and create standing waves. These are waves that appear to be standing still. Standing waves occur because of a combination of constructive and destructive interference. So how could you produce a standing wave with a rope? Well, you could tie one end of the rope to a fixed object such as a doorknob and move the other end up and down to generate waves in the rope. When the waves reach the fixed object, they are reflected back. The original waves and the reflected waves interfere to produce a standing wave. In summary, oh, I forgot about this. Another example of a wave is the wave that you do at a sporting event. And this one, even though the particles are in no way connected or touching each other, we do pass the energy of that wave down the line. So again, it's an example of a mechanical wave. In summary, wave interference is the interaction of waves with other waves. Constructive interference occurs when the crests of one wave overlaps the crests of another wave, causing an increase in wave amplitude. Destructive interference occurs when the crests of one wave overlaps the troughs of another wave, causing a decrease in wave amplitude, sometimes even to zero. When waves are reflected straight back from an obstacle, the reflected waves interfere with the original waves and create standing waves. So, if you think you understand interference well, please feel free to move on to the next activity. If you need a little more review on interference, you are also welcome to go back and review the video one more time. Thank you for being here, and we will see you next week. Go ahead and move on to the other activities before you end the week though, and make sure that you answer the questions and do the discussion. So have an awesome week. We'll see you guys later. Bye-bye.